Functions. When we do polynomial functions, the degree tells us how many curves or how many change in the direction. We're going to classify polynomials by the degrees. So if I have x to the 0 power, or the variable to 0 power, I don't write x to 0 power because anything to 0 power is 1. So that would be just a constant. So if I have 6, that's also a monomial. If my degree is 1, for example, x plus 1, my degree is 1. We never write the 1 though. So that would be a linear term because this graph would form a straight line. So I have 2 terms here. There's 1 term, there's 2 terms, so that would be a binomial. So if my degree is 2, it forms a parabola. So it's going to curve. So it's going to curve start up, end up, or curve going to start down, end down. So if I have 2, that's called a quadratic. I have 1 term here, so that would be a monomial. So I'm going to look at my degree. My degree is my highest exponent. So my degree for this one is 3, so that's cubic. So I have 3 terms here, so this one's a cubic trinomial because I have a degree name and I have a number of term name. If my degree is 4, so in this polynomial my degree is 4, quartic. If you think 4 quarts in a gallon, this quart would be 4. So I have 2x to the 4th, so it's quartic. I have 2 terms though. Here's my first term, here's my second term, so that would be binomial. Yep. So to the 5th power, the highest degree is 5, quintic, because quin means 5. So this one is quintic monomial. So if we get more than 6, we would say a polynomial to the 6th degree. Like if we get more than 3 terms, we'd say a polynomial with 4 terms, or however many terms it has. So in problem number 1, we're going to classify a polynomial. We're going to give it a degree name, and then we're going to give it a name by the number of terms. So I have 3x plus 9x squared plus 5. To be in standard form, I have to go with highest degree to lowest degree. So I'm going to rearrange this. The operation goes with the number in front of it. So that's why I have 9x squared, because it's positive. And then I have 3x. So I have 3x, and I have plus 5. So I have the 2nd degree. What kind of term is it? It's quadratic, because I have squared. I have 3 terms. It's a quadratic what? Quadratic trinomial. Nice. So in problem 1b, we're just going to write this in standard form, then we're going to classify it by the degree and number of terms. And if you notice here, we only have 1 x to the 4th. So I am going to write x to the 4th. But then I notice I have 2 quadratic terms. I have negative 6x squared and I have plus 10x squared. So I'm going to combine those. Operation goes with the number in front after it. So I have negative 6 plus 10 is 4x squared. So I got 4x squared. 4x doesn't combine with anything, so I got 4x. 12 doesn't combine with anything, so I got 12. So now I want to classify it. What's my degree? My degree is 4. And what do you call it?
What do you call it when it's a degree 4?
Quartic.
Quartic. Good. Quartic. Yeah. Just like 4 quarters in a dollar, right? Quartic.
I have 4 terms, so I'm going to call it a quartic polynomial. You could say 4 terms if you want. Or if you just tell us 4 terms, that's fine. So when we describe polynomials, we're going to talk about end behavior. Where they start, where they end. So I have x squared plus 1, which is a parabola. So this starts up, ends up. So the number of turning points, if I go from here, that's 1, and then it changes, that's 2. So if I have x cubed, I'm going to start down here, and then it's going to curve and end up. So I'm going to start down and end up. So we're going to look for a pattern here. If I have x squared, I start up, end up. I have x cubed, I start down and end down. And I have x squared, 2 turning points. X cubed, 3 turning points. So x to the 4th, I'm going to start up. I'm just going to make this little wiggle, and I end up. I have 4 turning points. 1, 2, 3, 4. So if I have an even degree, if I have x to the 4th, x to the 6th, x to the 10th, x to the 100, they go in the same direction. So if I have an even degree, starts up, ends up. If I have an odd degree, like n to the 3rd, made that N shape, all odd degrees will be in opposite directions. If it starts down, it's got to end up. It's an odd degree. And degrees are also the number of turning points. So if we had x squared and we had negative 2x squared, what does the negative do to it? Flips it upside down, right? So if I had negative 3x squared, I start down, end down. So if I had negative 4x to the 5th, normally an odd would make an N shape, kind of an N shape, which would start down, but the negative flips the whole thing over. It would start up and end down. So here's a table about our end behavior. So if A is positive, if I have an even degree, x squared, what's my direction? Where does it start? Starts up, ends up. If I take that x squared and make it negative, where does it start? Down, ends down. If I have my coefficient A is positive, but I have an odd degree, think of x cubed, makes an N shape, where does it start? Starts down, ends. Okay. If I take it and make it a negative x cubed, yep, up and down. So in this problem, we're describing the end behavior. So my degree here is 4. Degrees have to go in the same direction if they're even. So 4 either goes up, up, or down, down. But I have a negative coefficient, so it's going to take the whole graph and flip it upside down. So my end behavior, I'm going to start down, end down. So in problem number 3, we're going to graph a cubic function. If it's a cubic function, what's my degree? My degree is 3. So if it's a cubic function, my degree is 3, what's the shape of the graph? It has an N shape, right? It's going to go like this. It is going to look like an N. There's an N. So I want to describe the end behavior, the number of turn points. So I'm going to pick the easiest values to plug in, 0, 1, negative 1. So I'm going to plug in 0. So I plug in 0. 0 cubed is 0. Times 1 half is 0. So I get 0, 1. So I plug in 1. 3 cubed is 1, times half is half. Plug in negative 1. Negative 1 cubed is negative 1, so I get negative 1 half. So if I zoomed in, you could see more of an N shape here. So my end behavior, because it's cubic, it's going to start down, end up. Number of turning points 3, it's going to go 1, 2, 3.